Hi everyone, welcome back to my channel. You're watching Learn Tech with Sandeep Das, and in this basics video, we're going to cover the building CLI tools with GoLang. We'll briefly discuss one by one designing command line interfaces, then reading and writing standard input and output, cross-compiling for different platform of application that we're going to build, and finally, we'll cover packaging and distributing the GoLang binaries. I'm excited to teach you all that in a hands-on way. Let's get started. Now let's learn about designing command line interface. Okay. Now what are the steps of designing the CLI application? Very first thing, you should set up your Go environment by running a command called go mod init and space the project name. After that, you should be selecting the best CLI library. Okay. Now what do I mean by the CLI library? Okay. So you can develop a Go CLI app using the Go native module, which is using the flag module or say flag package. Okay. Now that is there, but there are already community developed, very good, very standard, very popular packages, which I personally suggest you should be using. Okay. And what are those popular options? Those popular options are Cobra, Unfab CLI, and Kingpin. Now, what is Cobra? Cobra is a highly popular and used in Kubernetes and Hugo. Now, think how good it is. Okay, and great for complex application. Then there is Unfab CLI, which is simple and easy to use, suitable for smaller application. And Kingpin, another very powerful with support for complex command line structure. Okay, now for this particular session or video, I have used Cobra because I found Cobra to be very powerful and very useful. Okay, that's why I'll be using Cobra. Of course, I'll be covering the native part also. Why not? And then I'll mainly develop one very good, say, DevOps specific application that we used for our DevOps cases, and then I will show you how to build that application. Okay, and then after that, you should have some kind of, usually you should have some error handling, then testing, documentation, and build and distribute. Okay, now in this video I'll particularly cover the build and distribute part after I build the particular CLI. So let's get started. So the very first thing you should do is run this command called go mod init, then the project name. Now project name, since it's day 6, so I'm just giving it the day 6. Okay, and you see this already exists because of course I've done all the coding and all this for you guys, right? Okay, so we have this day 6 module Go version here, and in the Go mod file I'm just explaining, and then we have the required modules. Okay, I'll come to the required modules later on. For now, let's focus on the CLI basic flag. Okay, as I told, there is two ways: using native modules or native packages, or using the community built, very popular, the packages or modules. Okay, now here we are particularly using a package called flag. Okay, and you're importing that. How you are going to utilize that? So for example, we can suppose it's a flag. Okay, so say we, or for example name, right? See, flag string name, so expecting a name here, and then flag parse after you define the flags. For example, bool v string name, and flag.parse will extract the values that you pass from those flags. I'll just run and show you how to pass the values and all. So let me quickly run this. It will become a bit more clear that way. Okay, so go run and this CLI basic flag. Okay, see, if there is no value, it's saying hello world because the default. So in the flag, if we have this flag package, right? So flag dot string. If there is, I mean, this is the flag name, the flag parameter, that is name. If you don't give any value, the default value is world, and this is the short line to describe what the flag does. Okay, or just flag description. Now suppose instead of just running go run CLI basic flag dot, what if you then go run CLI basic app and then name Sandeep. See, it's saying hello Sandeep. We successfully passed a flag like dash, then the parameter. Okay, just the parameter you're setting here, and then the value. This is how we can parse the flag values. Okay, now using the native flag module. or flag package. Okay. Now, same for the v. Here v is a boolean. See, this is how you're defining flag bool. There's a bool parameter, string, then it's a string parameter. This is how you should be defining the data type of the particular parameter that you are passing. Okay. Now, for example, flag also here, just say name Sandip. At the same time, we pass v. Okay, true. See, it's saying var was enable. So sometimes what happen when you run some things, usually it go normally. If there is any problem happening, you want a verbose or say show the logs, errors and all that. This is how in the command line cases we enable that. Okay, so this is a simple way of using the. So this is how using the flag package we can create a CLI app which accept the flags, okay, as parameter. And then we can, based on the values, you can do run our business logic and do anything that you want, right? Now that you have covered the native CLI development using the flag that package, let's cover the Cobra. As I say, Cobra is very popular package and even getting utilized in Kubernetes, right? So what it is, it's a popular library for using or building the CLI application. So let's come to this one later on. Okay, this is the main package which just execute the command based on the command input. Okay, now the important part is the command folder where you have the actual logic. Okay, so the main file you should be focusing on very first is the root.go and understand what we are doing here. Okay, so we are saying package command. Okay, this is, we are defining the package name. We're importing format os to handle the file related commands, and there are other things also we're going to do with os. Okay, then there is the this particular Cobra. So this is the main package, that Cobra package that we are importing. Okay, then this is the like root command, or say if you just say run the command, this will just show the details like what this command does, what this command about, a full like short description and a full description. Okay, so use the CLI particular what CLI to run, and then short, a very short description. Now this is just like, say we have this man, say cat, right? It just describe all these things, right? So this is how we define. We define in this particular area. Okay, kind of that way. Now we defining the use of the command name, the short name, the long name, and then we have a function execute. Now this only execute when you execute, of course, when you run the command. Okay, you pass the commands. Okay, we'll come to that later on. Okay, but you just execute the root command. Okay, and if any error, it is printing the error. Otherwise, just exiting. Okay? I mean, it's error and exiting and printing the error. Otherwise, normally it will just exit. Okay, important after root, the part comes to the actual commands. What are those? Say hello. Okay, what you're doing in the hello. Now, first of course, you're starting with the package name as CMD. Then you're importing the format package, just show some standard output, and then again here also we are importing the Cobra. Okay, so this is a modular way to keep adding different commands. Okay, and what command we are adding here? We are adding a hello command. So root is actually the main command, and hello, printer, all this we keep adding and adding are the sub command. So you have to also understand what is the root command. Root command is the actual command that you are running, and others are the normal sub command. Okay, so in hello, what you're doing, use is hello. So you just simply run the hello. That's how you're going to utilize it. Short, just a short description, print the hello message. Long, paste the hello message to return, like the long text that you want to supply. And this is the actual behavior. So this run part defines the actually what is doing. So see, run, then func, then is the input parameter accepting command, what from where is getting the command. Okay, so command, then the command that it received, and then it just all the argument is receiving and simply printing hello from C. But no, we're not doing anything with the arguments, but if you want, of course we can. Okay, so there is this very basic example, and in the function init we are adding the command. So root command is where this is where you added the root command, right? Now in the root command we are adding the commands. So see root command, then in the hello root command dot add command. This is how we are keep adding the commands in the root command. Okay, as a like sub commands you're adding in the main command. You can think that way. Okay, similarly printer. So here also we are importing the Cobra package, of course the format package, to just print the strings and strings to manipulate the strings. Okay, now here's the command definition for print command, and this is the variable which store the command definition. Okay, and we are creating the command is like and cobra.command. So this is the command definition part where use print, then the print text, whatever text you input after the print command. Then short description. I mean, short description should must give, but the long one is actually optional. See, in the hello I've given long, but in the printer command where you can skip that. Okay, you can say how many arguments you expect. For example, argument cobra.mean number arguments 1. So if you don't give after the print command, you don't give any other test or any value, it will throw errors. Okay, and now you also know that run command is the part where you actually do run your business logic. For example, we have format println strings.join argument. So we are of course getting the arguments hold the actual value. I'm just printing the value. Okay, this is what you're doing simply. Okay, and again here also on init function we are simply adding the print command. So root command dot add command is the print command. Now how this root command actually define the root, then it's coming into the hello and printer, because see the package name is what command, the package name is what command, the package name is what command. So if you define a package name and all the files you define the same package name, then it can access the from other files if the package name is same. Okay, so yeah, in root you see we didn't use it in it because we want in the printer command on initiation and hello command initiation it should get added. Okay, this is the requirement here. Now enough talk, let me show you, or let me just run the command, it will become a lot more clear. Just run go run, and then it's actually inside the Cobra folder, right? So cd Cobra, okay, then run go run, then CLI Cobra basic, and then say hello. So if you run hello, it will print hello from the CLI. So what's happening behind the scenes? You are running what? This particular file called CLI Cobra basic, which is this. Okay. Now you understand what it's doing. So package is what? Package main. What is importing? What is importing? It's importing the day 6. Where you're defining the day 6 in the go mode. Okay. So day 6. This is the folder path. Inside that Cobra, inside command. Okay. So that's how inside command entire particular package you're importing, and what you're doing, you are doing command.execute. So you're just executing the command, so or just running the application in simple sense. Okay, so go run. The moment I say go run CLI, it says what is the use. See that part? Very interestingly, this is how you, when you use any standard application, these are the ways it shows, right? Usage, my CLI command, available commands, like completion, like hello print and all that, right? Flag age, help. This is a very standard way, isn't it? Now, this is, I mean, if you don't give any sub command to do anything, just run the main command. Normally, so for example, we run any normal say Docker, for example. Okay, see, it shows what? It shows all the commands, right? Exactly. So this is how they define it. This is how they made it. So we are running from the like 0 step or day 1. That's how we are doing very basics first, and in this video itself I'm going to show you advanced use case and just exactly copy pasted from the basic. Okay, so this is going to be very interesting one. Just see, focus. Okay, now if you don't give any command, for example, just like we did now, just like we did before, what happened? This particular root command will execute. Okay, and it just prints what it does, all the data. Okay, the moment you supply any sub command, for example hello, then whatever logic you put in the hello in the run section, that get executed, right? Similar way, the moment we say instead of hello command we say print, and if you just run print, no, you cannot run. See, this is an error it given, require at least one argument, because in the condition wise in the printer we specifically mention minimum argument should be 1, otherwise it's not going to work, right? That's why it gives the error, and just say error require at least one argument required. So next time when you run print, say hi, I am Sandip Das, and see print hi, I am Sandip Das. So printer what is doing exactly, it's printing print, then whatever the argument is receiving, it's just joining by the say this space. So that's how it actually is applied, right? So it's not like it's a complete string. The moment you are giving space, space, it is actually considering all the data as a argument. Okay, that's how it's printing it. But you can avoid that part also very pretty easily. Say hi, I am Sandip Das. You can provide, the moment you provide like this way, then it's a complete one string. Okay, so anyway, now you understand how we can define the basic command. So basic commands, like this is where you define the basic command. Okay, and there these are like after the root, whatever the file you add in the command, these are the sub commands. Okay, this is how we are defining hello, this is how we are defining the printer, and it's doing whatever we are specifying in the run section. Okay, hello also you see same exact format in the run section, it's doing whatever logic you put there, it will just run. Okay, now using this logic itself, I have developed a very good application of system data collection, which is in a DevOps space. We do collect CPU data, memory data, or this kind of data, right? So normally how it gets done, like normally you download the third-party application and then using that you do kind of this phase the data, right? Why not we build our own CLI app which collects the data and write to log file? Okay, this is what you're going to do now. So using this exact Cobra basic application, I just copy pasted and created a folder called system stat. Okay, now copy paste is not enough, right? We have to put our business logic. So first I've created a command called SIC. Okay, and this is the file name called SIC. The package is main, and it's just, see, the path is different now. Okay, so day 6, that which is the module name that you have defined in the Go mod, and then the system stat because there is a folder name, and then the CMD because in the CMD folder we have put all our logics there. Okay, so importing and we just executing our commands. Okay, now what are the logic we put in the this command folder of SIC or system stat? Now SIC means system information collection, short form. Okay, SIC. Now what you done there? So first thing, you should be always looking at the root. Okay, so root, we are importing format for standard output or printing the logs in console or printing the text in console. Then OS to deal with standard output, or not just standard output, it's deal. Now then OS is to, like, this is a multi-level of functionalities, but mainly you're utilizing for reading and writing file. Okay, then we are using, we're importing the Cobra, which is the how this command engine working, right? So what is the root command we are specifying here? So root command is using SIC. Okay, so root command and Cobra command. This is the root command we're defining, use sec, and we're giving this CLI app to collect the system information, and this app collects system information that can write to any file if needed also. Okay, now execute, it just execute the root command that execute, which is it collaborate, or not just collaborate, collect all the sub commands also. That's how you keep adding, and it matches and run it. Okay, that's what's done behind the scene. Now next thing is the CPU. So what is doing? CPU packaging, of course, CMD, import, format, and of course the package or the command package, which is Cobra. We are defining CPU, CMD, CPU command. What is, we are defining the command here? So command definition part here, use CPU, short, which is the CPU, get CPU usage, short info, you can say, a line, short line info, and all the business logic we put in the run function. So CMD, Cobra command, arguments, all the argument is received this way, and we're just doing what? We are doing get CPU usage. We are running this function. I'm coming to where this function is, but just say it's a function that returns as the CPU usage data. Okay, we are printing the CPU usage data as a result, and then we are exporting to file. Now this export to file result, export file path. This export file path is actually defined somewhere. Again, I will show you where we're defining just in a few seconds. That in init command, you see root command, we are doing two things. Okay, first we are saying root command, add command, CPU command. So it's adding the CPU related command to the root command. Additionally, we are saying CPU dot flags dot string var p. So we are adding one string variable as a flag. Okay, which is what? Export file path. So whatever value we have for export file path, whatever value we pass will be overwritten with that particular variable value, which is how we are saying and that particular the variable, so that it's a pointer, right? So pointer value will keep change. So this is how we are defining the variable, flag variable in more simple sense. CPU command dot flags dot string var p, that, and this string var p means what? String var pointer, and pointer what is applying? The pointer value, right? So and export file path. There we are saying export. So this is the long form of the flag. This is the short form of the flag. This is the default value. Default value is not giving anything, and this is how we are saying like export to file. If you provide any particular value for e flag or export flag, then only this particular variable will have the value. And in this function, actually I'm checking if there is any value for this particular one, then only I'm writing to the any file. If not, then I'm not writing it. Okay, we'll come to that, all this thing. Similarly, we have the disk.go. Okay, what is doing? Exact same see basic part. So package command, import the format, and then Cobra. The difference part here, the variable name is the disk command, and we are defining the command definition here. So use disk, then short, so get the disk usage, and then in the run we are putting our actual logic there. The result variable is storing the get disk usage data. You are printing it, and you are exporting to a file using again here also you see exact same format, root command, add command, disk command. So we are adding this disk command to the root command, and then we are adding the flags. So disk command that flags string var p, so string variable pointer and export file path, then export e, and you know this part, the long form export, the short form e, and then the file value you have to supply. Okay, same for the memory, exact same, only the command will be different, the command definition will be different. So use is memory short, and then the run part you put the actual logic, again the get memory. Now this functions, get memory usage, get disk usage, get CPU usage, all these values, or all not this value, all this function, you have defined this particular file called stat. Stat, what are you doing here? We're importing OS, strings, time. So we are using this COPS utils to calculate the CPU, disk, and memory usage. Okay, and of course we are importing the Cobra This is how we're defining the main comments, right? So let's go down. See, this is the CPU usage. Okay, so where we are getting the CPU percentage, and we are just returning it. Okay, see, return format the particular value. Same for the memory usage. We are running mem.virtual memory function to collect the memory stat data and then returning it. Then get disk usage. Same here. We have the disk stat. We are just getting the disk usage data and storing in the disk stat and returning the value. And in the export to file particular that function, we have two. This is the data part that you are supplying, and this is the file path. A file path coming from where? File path coming from the flag. Flag only you are putting the value of the flag whatever you get into this particular variable file, right? But if it doesn't have any value, which is if not equal to blank, then only we are putting all the writing logic. Otherwise, it just get ignored. Okay, this is the option. That means this flag file writing is an optional parameter. Okay, so let's run it and it will become more clear that way. Always the moment you run it and the more you play with it, it becomes clear. So let's just go inside this particular folder called system stat and just run go run and then this particular command, that is the sic. So sic.go. This is the file, but we can run, of course, we can build of this one and make a command out of that, right? And we'll be doing this shortly. Okay, then give the, say I want to get the CPU usage, so just run CPU and see it will give us the CPU. Now this warning part we can ignore for now. And by the way, if you have the, I mean what I want actually, you guys should create a pull request of my repo, and why not you guys try to fix it. I know the fix, I can add it, but it will be interesting to see how you guys want to contribute more. Okay, so this is how you can get the CPU usage. This is 25.23%. Now for example, I want to get the memory usage, so memory and see 31.75 the RAM is or the memory getting utilized. Then suppose I want to get the disk usage, so I'll say disk and see is 15.31% of disk usage, free and all that in bytes is giving. Okay, so this is how we can define a advanced so you can create advanced CLI using the GoLang with the help of the Cobra. Now I think one part I'm missing, right? Writing to a file. How can you do that? For example, what if I run go run sig, I want to run this logic, for example CPU usage data, so CPU, then store in E, that is export, short form export. If you go to CPU and see, this is the flag, right? E, so dash E, then current folder. You can give any path, to be honest, and see it will create a file. Oh, it's a direct, I mean I didn't give the file name, right? So dot say CPU usage dot txt. I mean the path should be by default, if nothing proper, it should always go to a different, maybe downloads or maybe file logs, that you have to do, you can add on. I'm just being more flexible and writing in the current folder because this is how we're supplying dot slash, right? And see it's written the CPU usage this, right? Now this say I want to write the disk usage, so disk then E dot then and then disk usage dot say txt, it's fine, or txt. See is written the disk usage data, so disk usage total 15% getting utilized. Okay, of course the timestamp, because in the stats you can see I'm writing the timestamp and then whatever data is going, I'm just formatting, removing the new line and just putting there. Okay, then same way just go for the memory, so go run sic.go mem E, then mem usage, and see it will create a file called mem usage, and this is how. Now if you can ask me, Sandeep, I mean, this is not that great. I mean, you have to, for CPU you have to run again, for memory you have to run again, for disk. Why not we just run one command to get it all done? I mean, of course, you have very flexible. I mean, we are very flexible. We can do develop your programmers. We can develop anything. So for that reason, I have this particular file called stats. Okay. So what you're doing here, see, in stat I have already defined everything, right? All the function and everything is defined, and it's part of what the command. This is how all the function getting shared between cpu.go, disk.go, mem.go, because everything is part of the package cmd. Okay, so stat also I have put a command, and what this command does, this stats command, it just if we just run the command, I'm just going to run in few minutes. Just explain, let me explain first. So in this stat, if you just run go run stat, okay, sorry, go run sic and stat, then it will just get all the CPU usage, mem usage, and the disk usage data all at once, because I'm running all the three functions. This is the code reusability, because we have defined as functions, right? And we're sharing the function between all the other modules. Okay, so this is how we are calling the function. And then now how another one thing, how this function getting shared, and the reason is that function at the function name, it's G is capital. So function always at the name, the beginning, the first character should be capital. Then only it will get exported to other files, otherwise not. Make sure you remember that. Okay. Anyway, using CPU, I mean, we are calling all the three function, and then you are storing the result variable. Okay, so we are just joining CPU usage, mem usage, and disk usage data, and just printing it. So let me just quickly run it. So go run, then sic.go. This is system information collection.go. Then the stats, and see, it will print the CPU usage data, the memory usage data, and the disk usage data. Okay, now why not we just collect all the data and write in a log file called stats.log, for example. We can do that very easily. So just the same command -e, because the flag, and then simply mention the particular path, for example /, and we can call it stats.log, and just run it, and we'll create a file called stat.log. And see, there we have what? We have the CPU, I mean timestamp, of course, then the CPU usage data, and the disk usage, and all the data we have here, right? So this is how we can build a robust CLI application using the GoLang Cobra module. I hope you like it. Now let's move to the next topic. Now let's learn about the reading and writing to the standard input output. Okay, what it is. So in Go, the FMT format package is commonly used for reading input from the user. The scaling function of this FMT package is one of the simplest way to read the input, and of course the print and println function of this FMT package is to output to the console. And just refer to this particular example, very easy example. Okay, just package main, we're defining the main package, we're importing the FMT package, and then we're running function main, and in the curly braces, or say the code block, we're saying the var input string. So we're just saying input say variable as a string, then format print, the source say fmt dot print, we are asking to enter the text, which is the standard output, by the way. Then fmt dot scale in, and then you are passing a pointer to the input. Okay, so and input, which is it will get the value from the user input or console input and put the value into the input variable. Okay, and then you're printing whatever data you're getting. Now let me quickly run this into the actual application and explain a bit more. Let me show you. So the basic example of this read write you'll find in the basic.go under the read write folder, and this is again the example that I've just shown now. Package main, we're importing the fmt package. Okay, and also format package, whatever to call it. Then in the main functions, function main, we are defining the var input string. So input variable is type string, then we are printing to the standard output, say enter the text to the console, and then you are using the formats or FMTs, okay, and we are supplying the pointer to the input. So an input means pointer to the input, so that whatever the value user put in this input standard input, the value will get stored into the input variable, okay, and then in the using the formatted println, which is again the standard output, you are just printing you entered the actual input that is entered by the user, okay. Just quickly run it and show you how it works. So go inside this particular folder, that is cd read write, okay, then run then the basic.go, and see it's asking for enter text, which is this, okay, the format package or fmt package, the enter text, okay. Let's say hi, and if you just do it, see it's entered, you entered hi. For example, you enter hello, it will print to the enter hello. So this enter text part is coming from here. This you entered, this part is having from this println, and this input hello part, that is you put from your console or command line, that is getting stored in the input variable. That is how it's getting printed in the hello. Now let me show you one extra. If you just run the go run basic.go and enter text, say hi, how are you? If you do that, it will error, because see hi part will work, but the rest of the things, how are you part is saying that command not found, because it cannot accept the chunk of the words, okay. If you want to accept a full paragraph or say multiple lines or multiple words, I have given another good example called advanced.go. You see, I'm using the buff.io format and OS package. OS package is just the store whatever text you entered into the final, in the main final say file that will come later on. So you're opening a file in the write mode, say create or write only or append mode, okay. Then if it's no error, it's fine. If it's error, it will just print the error and it will just exit, okay. And defer file goes. We are not closing the file immediately, but later on we'll just close it, okay. First, then we are creating a writer. So writer, then buffio.new writer and the file. So it will just write to the file, okay. Now what you're doing here, this line is actually pretty important. So last time what happened, you just put multiple words and boom, you started getting errors, right? That you will not get here, because you are using the buffio buffio.new scanner, then OS the standard input, okay. And it will just keep writing and writing till you have this exit. So what I'm doing here for scanner.scan, so this scanner I'm just running as a loop and say for scanner.scan, every time you enter the input text is fine, it's just getting the text and storing as an input. The moment the word input is coming as exit, I'm stopping it, okay. Otherwise I'm just keep writing to the standard out, I mean this is file, okay. And then finally I'm just writing the file. So let's say we have this blank output, you can just delete also this file, it's fine. Now just run the advanced, go run advanced.go. If you just say enter text, hi, I am Sandip Das. See, I'm putting this, and in this output this file is created, because we just in the first line itself we are just creating the file, but it's not storing anything here. The moment we run enter, see now it's stored. So this particular file advanced.go, see every scanner, the moment you say enter, that means it's done. Next it will again start us to write it, okay. That's why it will not go exit. To go exit, we have to run out of the loop called break, okay. So it will keep scanning and scanning till you say exit. That's why for each new line, or say for each new line of course, or say new loop, it will keep running. For example, and what happening in the output does too is just creating that enter new line. Now let's say AWS hero, enter new line, okay, and see that just enter here. Now if I put exit, see, this is exit, and you're not asking to input anymore, right? And if you go here, that exit is not getting printed, because in advanced.go, if it's just input exit, then it's just breaking the loop, so it's not scanning anymore, it's not asking the input anymore. Okay, so this is a very advanced use case where you want the user to put a lot of text data for any reason. Okay, you just want them to input the text data into their standard input, and not just one word but multiple words. And sometimes we just ask the user to have some kind of command to stop the stopping the command loop. Okay, so that is where this exit command coming. Okay, and how we achieve that? We run the scan, we keep getting the text, and the moment the text value is exit, we are breaking the loop and we are not asking to input anymore. Okay, so this is how we achieve this. Okay, I hope you now understand the basic use case where you just entering a word and space is not working anymore. In advance, where you're using this Buffalo package, we can have this multi-words input with the option to exit also. Okay, that also we now covered. I think now we move to the next topic. Now let's learn about the cross compilation for different platform. Okay, now the build that I do using the Go build for our source code is not going to run in a Linux or in a Windows. Okay, so even though the source code stays same, we have to generate the build targeting to different OS and different CPU architecture. Okay, and that is the reason we have this particular you can say Go build chart or build matrix using the OS and the CPU architecture. Combining those two, I have different commands. Okay, now let's understand this in a very deep dive way. Okay, because this will be very important for your DevOps use cases. Okay, Go support cross compilation, which allows you to compile binaries for different platforms like Windows, Linux, Mac OS from a single source code. We use two environment variables. First one is the Go OS, that is Goose, and the second one is the Go architecture, in short Go Arch. Okay, and using these two environment variable we use to specify the target OS and architecture or the CPU architecture. Okay, now what are the Go OS operating system that we support? That is Darwin, Linux, Windows, FreeBSD. Okay, and then what are the CPU architecture we support? That is the AMD 64, the 386 ARM, ARM62, which is the most popular one. Along with them, there is like say ARM5, 6, 7, PPC64 and all that. Also Go build supports. Okay, and the most popular commands or say build platform targeting commands I've already mentioned. Okay, so this should be good. Now let me quickly show in the code that how we generate the build, and it will become more clear. Now for this build part, I have already written the command in the readme of this particular basics folder, and I'm going to run this particular builds for the this one. Okay, that's system stat that the CLI app that I've built. Okay, I hope you're going to utilize that way. So go to that particular folder, the cd system stat, and then run this one. Okay, so now not just okay, this just this one. So my app, let's call it the SIC Darwin AMD64. See, it generated the binary SIC Darwin 64, like SIC Darwin AMD64. So let's replace the my app with SIC. That will be more legit. Okay, now let's generate for the ARM64. Okay, so we have generated for the ARM64. Let's build it for the Linux. So Darwin for MacBooks. Okay, say for the Linux we have generated the SIC Linux AMD 64. Then the for SIC Linux 36. then SIC Linux ARM. Okay, see, I'm generating all that. Now SIC Linux ARM64, and this is where for Windows also will do, and for say let's just do for the FreeBSDs also. Now, what are these AMD 64? What are these FreeBSD 36? What is this ARM? So mainly the FreeBSD, Windows, Linux, Darwin. This is no OS, right? Darwin for the Mac, Linux for the all the Ubuntu, all the any Linux operating system, Windows for Windows of course, and FreeBSD is another OS. Okay. Now let me try to run these binaries to understand a bit more. Okay. So this SIC Darwin AMD 64. Let's try to run this. So SIC Darwin AMD 64 that we generated. This is for the Mac OS, right? And let's try to get the memory. So mem. Oh, okay, of course. This you have to do like this way, and you are able to get the memory data. Let's try to get the disk data. See, this is also worked. Now, the moment you try to get the CPU data, it will say CPU usage not implemented yet. The reason being that the CPU is different. The CPU architecture is different. So you try to work with the CPU and it's not going to work out. How to get it work? For that reason, because M1, this particular MacBook is actually M1 chip. Okay. So for that, that is the ARM64, not AMD64. So if I just run this one, SIC Darwin 64, I just have to add that executable at the beginning, and then if we just call the CPU, see, it's going to give us the CPU usage data, because this doesn't support the architecture. This is AMD64, but my MacBook is M1 chip, which is ARM64. That is why ARM worked. Okay. Now what if I try to run this one? So, and say for example memory data. See, execution format editor, because the export the way it exported is for Linux and not for the Darwin or Mac. That's why it didn't able to run. Of course, if I try to run the exe file, is not going to work. Okay, so this is a build specific way to generate builds for different OS, and that OS of course can have different CPU architecture. So for that CPU architecture, this is how we do it. Now I think you guys should understand a bit more deep dive way what are this CPU architecture like AMD 64, ARM 64, 36, all that, right? So let me explain all the CPU architectures so we'll have a better understanding of all this. Now let's go one by one for all the CPU architecture. First one is the AMD 64. So AMD 64 is a 64-bit architecture for 86 processor like Intel and AMD. For example, modern desktop and servers like MacBook Pro or Windows PC with an Intel Core i7 chip. Then the 386, it's a 32-bit architecture for into 86 processor. For example, older or low power systems such as an early 2000s desktop running in Windows XP. Third one is ARM CPU processor, which is a 32-bit architecture for ARM processor. Example are Raspberry Pi models up to Pi 3 and other ARM-based embedded system. Then ARM 64 is a 64-bit architecture for ARM processor. For example, Raspberry Pi, Apple M1 chip, or high-end smartphone and tablets. Then ARM 5. So ARM version 5 architecture examples are older ARM devices like early smartphones or embedded system. ARM 6 architecture example like Raspberry Pi or say Pi 0. Then ARM 7 examples are Raspberry Pi 2 and many Android smartphone of older smartphones. Okay. Then PPC64, it's a 64 architecture for PowerPC processor, for example, older IBM or Apple server workstation processor. Then PPC64i, it's for 64-bit architecture for PowerPC processor with the little endian or byte order, for example, modern IBM power system servers. Then MIPS and MIPSL, little endian, MIPS 64, MIPS 641E, which is MIPS architecture used in some embedded system For example, network equipment, older routers and IoT devices. Then S390X. It's a 64-bit architecture for IBM Z architecture mainframe. Examples are the IBM mainframe systems used in enterprise environments. And RISC-V64, there is a 64-bit architecture for RISC-V processor. Example, experimental or emerging system using an open source RISC-V architecture. Okay. Now these are the most, I won't say most common, but a very say detailed deep dive examples of different CPU architecture. Now I hope you have a better understanding of all this CPU architecture. Now let's come to the final part, which is packaging and distributing GoLang binaries. So what are the different ways you can distribute? There is major 4 ways. Okay. First one is the GitHub releases. So if your project is hosted on GitHub, use GitHub releases to distribute your binaries, which provides a centralized way of and version controlled way to manage the releases. Then package manager. For example, for product distribution, consider packaging your application for package manager like Homebrew, which is for Mac OS, APT for Debian or Ubuntu, or Yum for Fedora. And the cloud storage. For example, like services like AWS S3, Google Cloud Storage, or even Dropbox can be used to host the binaries. And the fourth popular one, that is the Docker images. So if applicable, package your application in Docker container and distribute it via the Docker Hub or any container like AWS ECR or Google Containerization GCR. Okay. Now let's understand about the versioning distributions. Okay, so there is 2 mechanisms there. So semantic versioning. Now semantic versioning, often abbreviated as SEM, is a versioning scheme for software that aims to convey the meaning about the underlying changing releases. It's composed of 3 segments, which is major, minor and patch version, formatted as like major dot minor dot patch, like 1.2.45, like kind of that way you can manage. Okay. And then update mechanism. So consider implementing an auto update mechanism in your application, or provide a clear instruction for updating the binaries. Okay, you by now you know that you can use the APD or say Yum to update the packages, right? So that kind of mechanism should be there if you want to utilize this. Okay. Now let me just give you some tips about how can you archive the files and push to GitHub releases. So to archive the file, you can use for Linux and Mac, particularly use a tar package, or for Windows, you can use the zip package to package your binaries and necessary files and everything, so that you can share with other people. For example, tar-cz vf space the zip file name and then space the source file name, or zip for Windows cases, zip my app windows.zip and space the particular Windows file or the final binary that you want to distribute, and you can zip it. Okay, and then use the GitHub releases to upload the asset into the GitHub releases page. Okay, which is now releases are actually based on the GitHub tags, which marks a specific point in your repository's history, and it's common to use semantic versioning. Now by now you know what the semantic version is, right? So use the semantic version to use for tagging only. Okay, for example, git tag -a then v1.0.0 m, just give you the commit message, that's git the release version 1.0.0, and then git push origin, you have to just push that one, that particular tag. Then gh release create a particular tag that you've created, and give space and provide all the file path that you want to upload to the GitHub repo, and then give us title. So just pass the title tag and then pass the node tab, and that's how it will just upload the file to the GitHub repository. Okay, now interestingly, if you see the gh command, you can think of a use case. Why not you learn that in the Go you can create a similar kind of gh command and do all these kind of things. It will be interesting challenge, isn't it? Now I'm open to the challenges. Just think of the challenge that you're going to learn today. You can, or you should be utilizing that like knowledge to do more, to do something better. Now, I hope you learned something new today and you'll be utilizing that knowledge for your day-to-day life, automating some things. And if you did get something useful in this session, please do subscribe my channel and like this video, share this video with others so that it reach out to many people. Okay, see you soon in my next video.